Hello and welcome to today's webinar for V-Ray for Unreal. My name is Valentin and I am a 3D specialist at Chaos Group. As a 3D artist from the game industry, I have gained a lot of experience in the Unreal Engine and I would like to share some tips with you. In today's webinar, we will cover the complete workflow for transferring 3D assets in Unreal Engine and focus on the areas that V-Ray for Unreal improves. We will follow a typical workflow for getting to Unreal Engine, and we will address the parts where V-Ray for Unreal improves that workflow. I will walk you through the entire process of transferring a project from Freeze through Max to Unreal, baking its lighting, and setting up some post-process effects. Finally, I will show you how to set up a VR camera in Unreal and walk you through the interior scene that I've transferred. Also, I would like to extend a thank you to the artist that you see on the screen, who graciously enough provided us with the scene that I'll be using today. First, let me tell you about V-Ray for Unreal. On one hand, it shortens the gap between photorealistic ray tracing and real-time rendering. It allows V-Ray users easily to take their projects in real time without forcing them to change their already existing workflow. On the other hand, it's a photorealistic rendering engine for designers who want high-quality imagery and lighting in a real-time engine. Unreal is a game engine that's optimized for rendering real-time graphics, but those come at the expense of reduced quality, limited features, difficult learning process, and increased artist time spent on optimizations and tweaking. V-Ray for Unreal adds award-winning quality, improved workflow for optimal artist time, and better hardware resource utilization. On that note, let's get started. Let's begin with scene preparation. The first thing that needs to be done is to optimize the scene in Freeze through Max before I export it into Unreal. There are also a few things that we always need to be aware of when preparing our project for Unreal in Freeze through Max. To start, let's go to Cameras and let's switch to the table cam. Now, let's select the table. You see that the table has 3 separate IDs, which all of them use the same material in Freeze through Max. If I don't change that, the same material will be instanced 3 times in Unreal, since we have 3 IDs on our mesh. This can be a problem if you have 10 or 20 IDs in a single object. To reduce the visual clutter and change a single material, I'll change the IDs from 3 to 1. Also, for it to look correct in Unreal, our object needs to have light map UVs. Since the table doesn't have any, I am going to unwrap it using auto-unwrapper. This is a script that will get our geometry and perform an automatic flatten unwrap on the UVs. You can find this script in our forums or in the description of this video. In order to run the script, select Customize and then click on Toolbars. Under Category, I'll select V-Ray and you'll see it listed at the top as auto-unwrapper. Now, let's drag and drop it to the panel on the left so I can access it easily. Okay, now let's run the script while the table is selected and enable a Pen UVs channel. This will add a new UVW unwrap on channel 2, since our object already uses channel 1's UVs for the wood texture. If I don't select a Pen UVs, it will override my already existing UVs on channel 1, and I don't want that to happen. Now, let's take a look at the UVs by opening the UV editor. Alright, I'm happy with the result. Let's move on to another important topic, for which I'll use the fruits on the table to demonstrate. In the Material Slate Editor, you can see that I have already loaded the materials for the fruits. I have only textures loaded in all of my slots, except for the color correction node. For maximum parity and optimization, this type of node needs to be baked into a texture. I can do that by rendering the result of the color correction node to a texture. I'll simply give it a path where I want it to be saved and press render. Now, I'll delete the color correction node and I will link the new baked texture into the proper slot. Keep in mind that if your scene contains 3D noise, fall off, V-Ray dirt, or other procedural textures, they should always be baked into a 2D texture if possible. Those maps are not fully supported in Unreal, and we will get different looking results after import. Next, let's look at exporting the assets. In order to transfer the scene to Unreal, we can use 2 different methods. The first one is using the Datasmith plugin for Unreal. The second method would be to export a V-Ray scene. For this project, I'll demonstrate both methods to export my scene. I've already unwrapped most of the objects in my scene, but there are a few objects that don't have lightmap UVs. For them, I will use the datasmith export, since the exporter will automatically unwrap them and it will preserve the hierarchy of my objects while keeping my objects in groups. I can also use the datasmith exporter to export multiple cameras to use in Unreal. For this demo, I don't need that, since I'll create most of my cameras inside Unreal later on. It's time to export my datasmith assets, so I'll go to the Selection tab in FreeStudio Max and select my datasmith selection. Then I'll go to File, Export, Export Selected, and press Save. I'll leave all the settings by their defaults and then press OK. Okay, next I'll select some V-Ray proxy objects. As you can see, I have 3 trees that are V-Ray proxy meshes. If I export them with datasmith, they will be converted to geometry, and datasmith will try to unwrap them. However, those trees in my scene contain 2 million polygons each. Since the trees are placed outside, we don't need lightmap UVs for them. All I want from them is to cast shadows on my interior. I'd like to share an important tip. If I export V-Ray proxy meshes with the V-Ray scene, V-Ray will read them that they are V-Ray proxies and it will not generate light maps for them. In my scenario, this is exactly what I want. Now, before I export the interior as a V-Ray scene, let's make sure that I have only visible the things that I want. Let's go to the Selection tab again, select the datasmith selection, and hide it. Also, keep in mind that if you have V-Ray lights that are turned off in the scene, V-Ray will ignore them and not include them into the V-Ray scene. Additionally, it's a good idea when exporting a V-Ray scene to look through the main camera in the viewport. Okay, let's export the V-Ray scene. Right-click, go to V-Ray scene exporter, select the location, give it a name, and then press Save. And then export. Alright, all of my assets are exported now. The next step is to create an Unreal project. Let's start Unreal Editor and create a new blank project. First, I want to enable V-Ray in Unreal. I can do that if I go to the bottom of the pop-up window and select Manage Plugins, or go to the top and select Settings, Plugins. In the Chaos software selection, I will enable both V-Ray plugins, and then press the Restart Now button. Okay, I want to create a new level first. So, I'll choose an empty level. Now, I can start importing my assets. First, let's start with the datasmith assets. To do this, I will need to click on the datasmith icon and open my file. I'll leave everything by default and then press Import. As you can see, all the datasmith files come with a hierarchy from FreeStudio Max. Next, let's import the V-Ray scene assets. I'm going to leave everything by default and then press Import. Also, note that Unreal will automatically switch to my imported camera in the viewport. I'll take a quick look and check if everything was imported properly. As you can see, all of my assets were transferred from FreeStudio Max to Unreal successfully. Alright, it's also a good habit once we import everything to save our level before we do anything else. So let's go to File, Save All, and then I will give the scene a name. Next, I want to organize my scene a little bit in the World Outliner. To do so, I'll collapse the Unreal Interior 01 and create a new folder. Let's rename it and call it Geometry. Then I'll select all the geometry in my scene and I'll drag it into the folder. Now let's create another folder for our lights and do the same. It always is a good habit to organize everything in Unreal. This way I can easily make changes later on in my project. Finally, I'll make a new folder for my cameras. And I will put my camera in it. Also, I'll change the camera's name to V-Ray Physical Camera. And I will save my changes to the scene. Next, let's talk about look development with V-Ray. Currently, the lighting looks wrong. There are no shadows and no indirect illumination present. What I want to do is tweak the sun in my scene and see the effects it has on the lighting. Typically, this requires a pre-calculation of lighting, known as light baking, which is a time-consuming process. As you can imagine, multiple iterations will increase the overhead quite a lot. For situations like this, I can leverage V-Ray's interactive rendering to get a better representation of how my entire scene will look, without having to do test bakes in my scene for every tweak. Before we start the interactive rendering, let's first go to the V-Ray toolbar and head to the settings. Here, if I go to V-Ray CUDA GPU device select, I can select the devices that I want to use. I can choose any configuration of all the CPU and GPU devices that I have. In my case, I want to disable the GeForce GTX 970 since it's connected to my main monitor and it's used by Unreal Engine. I'm going to use only my RTX 2080 Ti. Also, I'll leave the NVIDIA AI denoiser on to get faster preview with slightly less accurate results, since I want only to set up my lighting. Okay, now I'll go to my V-Ray camera and start the IPR. I'm not happy with the lighting at the moment since most of the room is still dark and the sun's position is higher up than I want. I have a general idea of what the lighting in my scene should look like, so now I'm going to go ahead and make some changes to it. I'll select the V-Ray sun first and I'll tweak it a little bit. I want the sun to illuminate a bit more of the couch and also the painting on the wall. So first, I'll change the azimuth to minus 155 and decrease the elevation to 25. Now I'm getting more sunlight in my interior and it's much closer to what I want. Next, I will exit the camera and fly through the scene, and I'll take a look at different areas of the room to check the lighting. As you can see, the interactive rendering really helps me save time when I want to change the lighting. I can edit in real time and see how my final light bake will look in the end, without having to do test bakes in Unreal. Alright, as you can see, my shadows on the floor are a little bit too soft. So I'll change the size multiplier to 2. That will sharpen them a little bit. Basically, that will make the shadows from the plant on the window more defined. Once again, let's take a final look through our V-Ray camera and leave the progressive rendering to clean up a little bit before we stop it. This way, I can get a better feeling of the lighting in my scene once I bake it. Okay, I'm happy with the changes, so I'm going to stop the IPR, and we are going to move forward. Let's talk about light maps and baking next. The first thing I want to do is to go to my viewport options and change my screen percentage to 200, just to get a better anti-aliasing in my viewport. Note that I can preview the light map resolution of every actor in the scene prior to baking. To do that, we'll use the optimization view modes and select the light map density. The different colors represent the size of the light map resolution for each object. Blue means we have a smaller texture size for that object. Green is medium size, and red represents a higher density light map size. Let's start with the size of the light maps for the walls. Since they are large flat surfaces, I want them to have the maximum quality resolution. I will select the object and go to the details scroll down, and in the lighting tab, I will enable overridden light map resolution. Okay, let's first enter 1024. As you can see, it becomes orange, but I can still see the checker box on it, which represents the pixels of the light map. So I will enter 4096 to get the maximum size for that light map, and thus the maximum quality. Now, let's do the same with the curtains. I'll select both curtains and override the light map for both objects at the same time. And now I'll do the same for the rest of the objects in my scene. I'm going to speed up the video here, so you don't have to watch me go through each object. An important thing to note here is that the larger the light map resolution is, the slower the baking process will be. The reason I'm making the light maps larger is that I want to get the best possible bake quality. Once I do the test baking, I'll have a better idea if my light maps are large enough for the objects in my scene. Next, I need to select my lights in the scene, and in the options, I'll enable Set for Light Bake. This way, I can set them to be static, which means they will not cast dynamic lighting, and they will be affecting only the light maps. Now, I want to do a test bake to make sure that I don't have any flipped geometry, and to check the resolution of the light maps for the objects in my scene, like I said earlier. To do so, I'll go to the V-Ray Bake button and select Settings. Here, you can see that I have light baking quality set to 0. The 0 quality setting will start the progressive sampling of my light maps and use low settings for baking. It also denoises the light map once it's baked and moves onto the next light map atlas. This preset will give us faster bakes, but it will compromise the light quality in the process. Note that when I use the preview setting, I can always press the stop button on the render window, and then Unreal will stop the rendering. It will denoise the current result, and it will move on to the next light map atlas. But in this example, I'll just leave V-Ray to render my maps. Next, let's talk about the light map atlas resolution. This will determine the size of the light bake atlases. For example, V-Ray will automatically determine how many objects can be combined in one bigger atlas. Baking with larger atlases is faster, but it uses more computer memory and vice versa. Before I start the bake, let's go to the V-Ray settings, and I want quickly to show you the distributed rendering feature. Here, I can add other rendering machines to speed up the process of baking. The Use Localhost checkbox will allow us to include or exclude our workstation from the baking process. Note that the distributed rendering can be used for the IPR as well. Okay, let's start the bake, and then we'll continue once it's done. Let's talk about some finishing touches next. The preview baking finished for 2 hours and 41 minutes on my machine, only using my RTX 2080 Ti graphics card. Since light baking is a time-consuming process, I would always recommend doing a test bake first. In a moment, I'll talk a little bit more about why this is important. Let me first go to View mode and disable the game settings. Then, I'll enter an exposure value of 0, so I can see the darker parts as well. Now, let's inspect our light maps in the scene. Since this is only a preview bake, I'm aware that this is not the final quality that I'll get from my light maps, but it allows me to go through my scene and assess what objects will need a higher light map resolution. First, I want to address why my trees outside are dark and how to fix them. Since my trees are V-Ray proxy meshes, they did not get included into the baking, which is why they appear dark. I can fix that by adding a new light into the viewport. And changing the lighting channel from 0 to 1. I'll do the same for all of my trees. Note that we need to do that after we bake our light maps, otherwise the trees will not be included into the shadows once we start the baking with V-Ray. Now I can play with the light intensity to light the trees. Once I'm happy with that, I'll change the light map resolution of some of the objects in my scene, since they can use a little bit of higher light map resolution. Note that once I change the light map size, they will appear dark. This only means that they no longer are using the light map that I've baked using the preview preset. Alright, I'm happy with the changes, So now it's time to move on to our final light map baking. I recommend using at least a medium or high preset for that. With the medium preset, the baking will take 13 hours and 15 minutes, using only my RTX 2080 Ti to bake the light maps. Naturally, the high quality preset will take a lot more time. I recommend using the medium setting most of the time, and switching to high only if you see some problems with your light maps. Alright, now it's time to bake my final light maps. If you want to speed up your baking, you can always include multiple graphics cards or CPUs on your machine. And don't forget, you can use distributed rendering as well. Okay, let's take a better look at my final light map bake. I will fly through the scene and take a closer look at my final light maps. Keep in mind that V-Ray always denoises the light maps once they're baked. This way, we can always get noise-free textures, resulting in even higher quality. It's important to note that every time you change your light map's resolution, V-Ray will automatically find a space in your atlases for your light maps by rearranging them automatically or creating a new atlas for it if the resolution is too large. In the near future, you will be able to export your light maps baked with V-Ray from Unreal and even edit them in external applications. But keep in mind that they will be 32-bit floating point textures. Another awesome feature that we've added in V-Ray for Unreal is the ability to bake individual objects. This can be helpful if you need to do some tweaks on the geometry or change the light map resolution of certain objects, for example, and not have to bake the whole scene all over again. But we will cover that in a separate video. Once I'm done with the baking, the next thing I need to do is some finishing touches. In order to have better reflections in my interior scene, I need to add reflection capture actors. The reflection capture actors are like small cameras that look in 360 degrees and capture on a small texture everything around them. That captured information is used to tell the objects in the scene that are reflective to use that small sphere for their reflections. In order to have good looking reflections, I would always recommend to use multiple reflection spheres and try to keep them inside your interior scene, because if you place them outside of the windows, for example, you may end up with some strange reflections. I'll go to the Models tab, Visual Effects, and create a sphere reflection capture in my scene. You can see the effect showing on the vases when I turn on and off the reflection capture. Now, let's decrease the radius of the sphere. This will determine how far the sphere will affect the objects near it. I will speed up the process here, since this can take some time. You see the reflection effect on the curtains is too sharp. This is because it requires explicit baking of the light props for better looking reflections in the scene. Another important tip: place your spheres where you think the reflections of the nearby objects will be coming from. This way, when we take a walkthrough of the scene, we will see that our reflections behave similarly to the real world once we start walking with the VR headset. Once I'm done, let's go to the Build tab and select Build Reflection Captures. This will tell Unreal to take all the reflection spheres and bake them to capture more accurate reflections. Also, before I continue with anything else, I will make a new folder and I'll put all of my reflection captures in it. This way, I'll keep my scene organized so I can do additional edits if I need to in the future. Since I want to create more of an artistic look to my scene, let's now add some post-process effects to it. This will allow me to add additional effects such as lens flares, bloom, manual exposure, and other parameters that can drastically change the look and the mood of my scene. Now, if I go to the Visual Effects menu again, I can drag and drop a post-process into my scene. Let's disable again the Game View mode for a second. Then, I'll go to the settings of the post-process volume, and all the way down, I'll first enable infinite extent. This way, the post-process effect will affect my entire scene. Now let's start tweaking some of the settings. First, let's enable bloom to make the lighting a bit softer and more interesting. I'm going to set the intensity to 3.56 and the threshold to negative 0.14. Next, let's set the exposure to manual and set the exposure component to 9. To make the scene more lively, I'll also enable lens flares. Let's lower the intensity a bit. Also, I'll increase my bokeh size and threshold to 32. Since I want a specific effect for my lens flares, I will enable the bokeh shape and I'll plug in a custom texture. Now, I can immediately see the effect on the screen while I'm looking towards the sun. Also, to change the mood of my scene, I'll go to the color grading and in the global settings, I will turn on the gamma and play with it a bit to get the desired mood for my scene. Finally, let's add an Unreal camera into the scene. And let's set the camera to universal zoom, so we have more control over the focal length. Then, I'll go to details and change the focus method to none, and enter a focal length of 25. At this stage, I can go ahead and edit in real time the materials in the scene, and make them look more reflective or make some additional tweaks to them to get the final look that I desire, since the post-process effects will drastically affect the look and feel of your materials. Also, tweaking the materials at this stage does not affect your light maps, and having reflection capture actors will give you a more precise idea of how your objects will react when you play with their reflections. Okay, now let's do a quick fly through of the scene here to see how everything looks. Now, let's see how I've set up my interior to use the VR headset inside Unreal. I have made a few changes to the scene as well. I've tweaked the materials for the wall and the draw in order to appear a little bit more shiny now. I have moved the trees a little bit closer to the windows, and the palm leaves needed a little bit higher light map resolution, so I've increased its size a bit. Now, if I go to the cameras folder, you'll see that I have 4 Unreal cameras created as well. All I did was to duplicate the camera that I've created previously and position them throughout different locations in my scene. I've also oriented them to look in different directions. Another thing I had to do is add few more reflection capture actors here and there to get better reflections. Okay, let's set up the level for VR now. There's a plugin which I can use that will prepare most of the setup for me. First, let's go to the bottom of the screen and in the view options, I will enable show engine content and show plugin content. Now, if I go to the left and drag all the way to the bottom, I will see a folder called V-Ray Teleport BP content. I am going to go to the teleport folder, select the V-Ray Teleport pawn, and drag and drop it into the scene. Now, I need to make sure it's placed exactly on the floor of my scene, since this will be the lowest level the VR headset can go down to. Next, I'll turn off use camera height, since I just want the camera's positions on the floor and not their height. In the viewpoints list, I'll add 4 array elements. And then I'm going to place my 4 cameras in them. Alright, those are all of the steps required to set up a scene for using a VR headset inside Unreal. Now I'm ready to take my first walkthrough in the level. Let me put my VR headset on for a second, and let's press play. You should be able to see approximately the same things I see with the VR headset. Note that I'm using the controller's trigger to teleport between cameras. It's quite fun to be able to walk around and take a closer look at what I have set up. As you can see, the results are quite realistic and it gives us a great immersive experience. Okay, I hope this webinar was helpful for you guys and you have learned how to set up your projects from start to finish using V-Ray for Unreal. And thanks again to everyone for attending and sticking around until the end of this webinar. If you haven't tried V-Ray for Unreal yet, you can follow the link on the screen where you'll be able to try it out for free for 30 days. Thank you for tuning in and until next time.